So, here's your success criteria. I gotta fix this over here. Oh, that's not my eraser. So, what we're working on. Someone erased it and put something that I didn't like on there, and I said no. I did have to be on the first. Okay, so we're going to be operating on complex numbers today. So that means in order to be successful, you're going to have to add and subtract complex numbers, be able to multiply complex numbers, divide complex numbers, perform operations with square roots of negatives, and then solve quadratic equations with complex imaginary values in them. When I was going to high school, I always was confused by the idea of real numbers. Because when I was talking about, oh, it's a real number, it's a real number. Like, putting a number's fake. Well, they're not fake. We do have a set called imaginary. It's all like, okay, imagination. I know, I love it too. I'll probably be doing that. So, let's get started, yo. So, if you remember, we always called the square root of negative 1i. It's kind of hard to manipulate sometimes the square root of negative 1. And for those people that are wondering, if you're ever going to go into like electronics and computer programming and stuff like that, or building computers, they actually use I a lot, according to Mr. Morris. So I thought that was kind of cool, coming from an engineer, that it's actually used in the real world a lot. So here's what we have. Everyone understand the pattern already? Does anyone not understand the pattern on I? Let's just go over that real quick. Okay. So let's do that. And I'm holding my coffee like it's going to go away somewhere. Stay there. So we call the square root of negative 1i, correct? What do we call I squared? We call that negative 1. Reason being, if I have I squared and I can substitute that value of what it is, we know that squaring and square rooting are they're opposites of each other, so they undo each other. And if you want to call it cancel out in your head, make sure you put in air quotes up there, okay? Because they are undoing each other, therefore we end up with that negative 1, right? Then when we go I to the third, what do we call I to the third? That ends up becoming negative I, correct? Why negative I? Yeah, we have two of these scenarios, right? We have the original I in there, but then two of them do this for me. So I end up with a negative 1 times that extra I, therefore negative 1i, which we just call negative I. Okay? When we go I to the fourth, what do we call I to the fourth? It's not just I. It's not I squared. It's 1. If you think about it, I squared is I to the fourth is I squared times I squared, correct? And we defined earlier that I squared is equal to negative 1. So negative 1 times, how much is that? Positive 1. It used to be 4. Not anymore. Okay? So if you realize that pattern, if you know it, then you should be fine, because after that, I to the fifth, what's I to the fifth? It's just I. Reason being, 4 of them are 1, and the extra one will be behind. So 1 times I is just I. So this pattern after 4 repeats itself. It goes I, negative 1, negative I, 1. And then it repeats I, negative 1, negative I, 1. That's really nice because that allows us to kind of calculate things such as this. I to the 27th. I don't know. I heard a negative I. Any other guessers?
Is it really negative 3? I'm a genius.
So it's negative I? Okay, so how'd you do that so quick?
I guess.
Anybody have a method?
I divide 0.7 by 5.
By 5? That's okay if you want to do 5. I mean, you must have a method.
Yeah, I did by 5 because that was the first thing that popped in my head, and then I went to the 3 since that would be afterwards.
Okay, so what I would have done is to divide by 4. Because once I divide by 4, what do I get here? This 24? So 6, that's going to give me 24. I'm going to have 3 i's left over, right? And that means that I can look at that spectrum from, what is it, I to the first to I to the fourth. The third option is negative I in this case. Okay?
So really, it's not a genius without even knowing.
Go ahead, genius.
Oh, no.
I to the 123rd. What's that simplify to?
Negative I.
I don't know. I can't do it in my head. I can't divide like most of you guys. I use my handy dandy calculator.
I'm guessing 81.
It's still negative I again, huh? Because that 120 didn't.
That's what he did.
So again, take 123 divided by how much? How much? How much am I dividing 123 by?
12.
120.
No, divided by
120.
4. Goes in there once, you're going to get, what is that? What is it? Go in there once?
3 times. 80 times.
Goes in there thrice. It's going to give me 12, and then I'm going to have a remainder of 3. So I'm back at the other situation again.
Divided by 3.
Negative 5.
Exactly what I almost guessed.
Okay? Cool. Now, here's something very important to know. If they ask you to write a complex number has a real portion and it has an imaginary portion. Okay? Listen to what I just said. If they ask you to write a complex numbers have a real portion and an imaginary portion, right? Okay. Can I change this? Cool beans. So here's what I've got. Perform the indicated operation. Does adding 2 binomials really affect anything on the right? No. So I can do 5 plus 3, that's 8. And then negative 2i plus 3i
Plus I.
is plus I. There we are. Can you get a thumbs up, thumbs down on this? So far? Not bad. What? I'm okay. I'm gonna just. Can I change this slide? Go back one slide. Complex numbers have a real part and then imaginary part. Okay. All right. Cool. Here we go. Next one. Does subtracting affect my right side? Yes, it changes all the signs, doesn't it? So in this case, I'm taking 2 plus 6i, and I'm going to subtract from that 12, but I'm going to add I to that. So 2 minus 12 is a negative 10, and then I've got plus 7 i's. I only have 4 i's, but...
Very funny. Did a laugh. 10 out of 10 would laugh again.
Are we good here? Thumbs up, thumbs down? Blue? Da-ba-dee-da-da. Asun? Good? Welcome back. Okay, multiplying. Multiplying. Which property am I going to use for multiplying? The distributive property. This is going to give me 14i. This is going to give me negative what? 63 I squared. Uh-oh. I squared
Equals 1.
Negative 1.
is a negative 1.
So it's
So I'm going to get 63 plus 14i. Please make sure that you're fixing your solutions so that it's in its standard form. Real plus imaginary. Real plus imaginary. Or minus. What?
What's the dyslexia but with numbers? 'Cause I think
Arithmexia.
I
I replace.
Oh, wow.
100%.
It's not 100%, otherwise you wouldn't be able to read any of that.
Yes, I would.
Oh, really? No, that's math. Moving on. Here we go. In this case, we can still use our distributive property twice, aka FOIL. So we've got 30 minus 35i. Oh, that's a horrible I. Where'd I go? Here we go. Plus 24i minus 28i squared, which will turn this into a positive 28. So I've got 58 minus 11. There we go. What's the real portion? What's the imaginary portion? Negative 11i. Beautiful. Fantastico. Okay, before I move on, I want you guys to try something for me. Yay! Okay, here you go.
Oh, am I doing it?
Simplify. Simplify, Parish. Maybe I don't want to confuse you guys. No, I don't confuse you guys. What'd you get? What's wrong? Please read the instructions. That's wrong. Good job. It's so much pressure. Please read the instructions. That's wrong. Good job.
Wait, I got the same error as they did. For me, but that doesn't make any sense to me.
What does the instructions say? Don't cough on me. I don't want to get sick.
Anybody plays some guitar around
Okay, so what's the solution here?
here? 0 minus 3i.
Beautiful. 0 minus 3i. Because complex solutions have a
Equation.
and a if what you give me is only this, that's not complex. That's imaginary. How to make a point, yeah? Here's the beauty. Remember the conjugates rule? You remember the conjugates? When you multiply something by its conjugate, like let's say x plus 4, what's the conjugate of this guy? X minus 4. When I do this, what happens to the two middle terms? They do cancel out, don't they? In this case, they do cancel out. You would get x squared minus 4x plus 4x minus 16. These guys would make 0 always. Always. So, when we have complete conjugates, we can leverage that and we can do the first part and the last part, and then we would, but that's all, folks. I gotta slow down. I'm getting too excited here. Hold on. So, we talk about, thank you. Sorry, I was getting excited there. I can't even get I had like so many thoughts already at the same time. So, why do we have to learn that conjugate theory? Well, whenever we're working with stuff, now I'm going to throw out a full disclaimer. I know that there's talks about stopping this madness of rationalizing the denominator. Still hasn't happened yet, but there's talks about it. Well, you know what? With technology, our calculators understand that. They can calculate things like that. The reason why we have to do that was for us as people. Because if you think about this, let's say I wanted to give you half of the candy bar, okay? Like, I'm going to give you half, I'm going to share my candy and give you half, right? I think that people usually go, snap, here you go, and you don't question it, right? Because it's about half. That's okay, correct? But if I'm going to give you half of pi, the number pi, right? People go for blah, 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 blah. Do I have any idea of kind of where to break that? No, because that number goes on forever. So it's like, is it here, is it here, is it here? Then you really couldn't. I love it too. They have the 3 movies together at Walmart for like $10. I already own them, so I don't get to go buy them again. Anyways, so we have to do this thing called rationalizing the. I can spoke. Rationalizing the denominator so that we can have an idea of what that number really looks like, right? Thank you. So, we're still going to keep doing that. I think it's a fantastic skill for us to learn. But what we're going to do is we're going to leverage that conjugate theory so that we can rationalize our denominators, okay? Because I know that if I can take I and multiply it by I again, I would get a real number, right? I would get negative uno. But if I were to just multiply it by itself, it really wouldn't do anything for me. It would just make things crazier, and I'd be in this vicious cycle. But if I were to leverage, let me write this a little bit bigger. If I were to multiply by the conjugate, what would happen here? The 2 middle numbers would cancel out. And what I have to do only is going to be the first 2 products, 4 times 4, which is 16, and the last 2, which would give me a positive 1, right? Negative would make it positive. So then I have something real, and this is why we're leveraging that. But because I do it on the bottom, right, I got to maintain that equality there. So I'm going to do it up here, plus I, so now I have to use my FOIL method. So I've got, what is this going to be? 20 minus 4, 16?
Sure. Oh, sure. I got to 20, I'm
Yeah. Right? And then I've got 5 plus 16, which is 21. And there we go. And of course, that's just 17, correct? Okay, that's 20. That's positive 5i. That is a 16i. And this would be positive 4i squared. Sorry, square's on the wrong side. 4i squared, which makes it 4 times negative 1. So 20 minus 4 is 16. And then 5 and 16 is 21.
Thank you for
Okay.
explaining that.
So just spoiling that whole nonsense up there out, okay? I did that kind of weird. Let me see thumbs up, thumbs down. I'm okay with what you did. Which part? That's a little too much for me. Like double jointed there, bro. Do you know Mason? Howie? His can go like flat. Like he can do that and it's just kind of go like that. Like, oh, that's the wrong way. Okay. Oh, sorry.
Oh my, I didn't even get all that.
Oh man. I miss Usher. He's making more movies. Usher's good. For sure. Oh, I hated that. I hated when he did that. I think that he just messed it up. And then like, it was a good recording. And then they try to make it a thing, and they're like, no. There we go. Oh, wait a minute. You still writing? Thank you. For any positive real number, the principal square root of a negative number, negative b, is defined as negative root b. So, let me explain, Lucy. We know that there's no square root. Well, let's see. We know there's a square root of 4, correct? The square root of 4 is how much? 2. But we don't know what the square root of negative 4 is. Now, people say 2 as well, but that's not 2. Because remember what the square root is, some number times itself gives you what's inside, correct? And we're looking for that number. Well, in this case, I know that it's 2 times 2, which produces the 4. Hence, the 2 is my root number. But in this case, what am I multiplying to get 4? I can't do 2 times 2 because that's positive 4. And I can't do negative 2 times negative 2 because that's still a positive 4. So, do you guys remember what the opposite of multiplying is? Kind of dividing, splitting up. Because that's what you're really doing, right? So what we're going to do is we're going to split this thing up into 2 roots. We're going to say that that's the square root of negative 1 multiplied by the square root of a positive 4. Now it's legit, right? Yes? No? Maybe so? So, I know that this is going to be 2, and then I can rewrite this in the form that we understand, or that we've given it, which is the square root of I. So that just becomes 2I. And this is what the rule is saying. When you see that negative in there, just pull it out and call it I. And try to simplify your root as much as possible. Yeah, go for it. That's in my head now. Oh my God. Oh, what a great song. You know which was my favorite Usher song though? You Got It Bad? Oh man, dude, it's all about it. It's Usher. Okay. Usher. Oh, that's a good song too. Okay, children, here we go. You guys want to try? There's 2 problems for you. A little review here. There's 2 problems for you. Give you a few minutes. We'll come back together.
Upside down pie this thing. But how do you take something down that he said? Wait. Yeah, you can
It works better than talking to the wall.
I believe I believe 7 hours in square roots. I got 7. I don't know about that. I got 7. Man, I reckon 7 is the answer. Let's say it's 7. Where? Oh, yeehaw. Where's my?
What about me, my identification?
We don't want to be kicked out of these schools. So you're there more.
Okay, thank you. Let me draw your attention to the board. Most people got the first one okay? You want to simplify your radicals. I like using my upside down cake, so 27 is going to go 3, 9, 3, 3, right? For every 2, I could take one out. And I'm taking that negative out as well, calling that I. I've got a 3 left over. So I've got, now I'm doing the country accent. Why am I doing that? You got me doing it. 3i, radical 3 is on the first one. Let's take that 48, break it down. That's 220. 212, 26, 23. For every 2, I get to take one out. That's 4. I'm bringing out that negative as well. They are like terms because they both got a radical 3 in them. So I've got 7 i's and 4 i's, make a total of.
7 eyes, partner.
Hold on, what did I say?
That's crazy.
Did I start with 7? All right.
Oh my.
So 7i, radical 3. On the second one, some people are struggling here. This is just your distributive property. So here's what we're going to do. Let's fix this. That's what I was going to say. Let's fix this radical 3. Actually, we don't have to. You guys want to? Leave it the way it is? Alright, so we're going to have 4 plus 2 radical negative 3 plus 2 radical negative 3 plus radical negative 3 squared. Correct? Are we good there on the last one? I could barely write it in there. You guys make it out? So these are going to go undo each other. So I've got a negative 3. So 4 take away 3 is 1. And then I've got 2 plus 2, which is 4 radical negative 3. Let's take out that I. So I've got 1 plus 4i radical 3. Any part that I need to re-explain? Hopefully you guys can see this okay. It's pretty bunched up there.
So you're saying
I can't hear you. Go ahead. This part? Okay. So do you realize that this is just negative 3, right? So 4 minus 3 is 1. And then I'm just doing 2 plus 2, which is 4. This is going to stay the same until I get to here. At this point, I can pull the negative out and call it I. I. Yes. Okay? Cold root beer?
Are you saying that the pair of jeans would be just right? So, Mr. Munoz, you're saying that the answer here ain't 7? That is
No.
not real question.
I went too far. Okay, I go too country.
Have you ever heard that song? Rain is a good thing.
Which part, Kicker? Oh. I thought, yeah, my bad. I thought you were talking about something.
I really thought 7 was the right answer there.
Maserati.
I don't understand that.
Almost there, almost there. 2 more slides, peeps. 2 more slides.
Trying to go Buzz. My Bronco. My Ford Bronco. I'm just kidding. All right.
Oh, I love Ford Broncos. My father-in-law has one. It's a monster.
A Ford. I don't know. So,
I don't know if you guys seen it. It's white with the red stripe. It's got these huge wheels in it.
I guess that's all right.
I keep telling my wife, tell him to leave it in the wheel.
It would be great till it breaks down. This is a Ford.
Fords were like Motorola. You guys remember Motorola?
That sounds like.
Back then they had Motorola, the push to talks. Oh no.
Oh, I still got one.
You guys remember those PPTs? Those worked all the time. They either worked or they didn't work. And the amount that didn't work was very rare. And that's a Ford for you, man. Okay, going on. I don't know if I want to do that one. Where's my Malago people at?
That's me, right?
Okay, let me bring more care. Where's my Valago Alta people at? Oh, that's everybody. Here we go.
Can I sing it, sir?
1, 2, 3.
X equals opposite B plus or minus square root B squared minus 4AC all over 2A.
I had never heard that. But that was great to hear. Thank you. They don't have a song. The only song I've heard was from Alta that makes you guys do this, okay? So, before when we were doing these quadratic problems, sometimes you can get stuck here trying to factor, because factor is probably the easiest thing to do, right? Sometimes you just can't find those numbers. I think that you're better off checking the discriminant, okay? So let me go back real quick to the quadratic equation. As you look at the quadratic equation, what's inside of this guy will tell you whether you can factor it or not, okay? If it's factorable, the number that comes out of there is going to be an integer, okay? It has to be an integer. So if you get in there, you start getting to radical 4, then you're good because the square root of 4 is 2. But if you end up with radical 5, is that factorable? No, because there's no square root of 5. So once you finish up the whole square root piece, if it's an integer, then it's factorable, okay? The other beautiful part about that is that the discriminant, Kennedy, will tell you whether there's going to be one solution, 2 solutions, or no solutions. Now, I think you probably heard that. I bumped my funny part. As I slid off. That feels so weird.
I'm glad you done said it.
Okay. Thank you. So please do not confuse what I'm about to say with the factory business. If what you get there is an integer, then it's factorable. If the discriminant is greater than 0, I should say greater than 0, then you are going to be able to get two real solutions out of it. Two real solutions. That means that you have some parabola that crosses, I don't know where, but it will cross twice. Simple enough? Okay? If your discriminant is equal to 0, then you're going to get one real solution. Solution. That means that your parabola simply just touched it. So it kind of came down, hit that x, and then bounced right back up. Okay? In most cases, what you'll get there is what's called duplicity. You're going to get the same solution twice. Duplicity. Okay? If that discriminant is less than 0, then you're going to get 0 real solutions. Excuse me. Salutations. Real solutions. That means that your parabola is above that x-axis and never really comes down far enough to cross the x-axis. So you're going to get what's called two non-reals. Fact of the matter is, though, that you're going to get two imaginaries. Two imaginary solutions. As we get into this, you probably will have quadratics and polynomials probably that are of great degree. And if you remember, then the degree of the polynomial tells you how many zeros you can have. You must be able to account for all of them. Some will be real, some will be imaginary, but you have to be able to find them all. Gotta catch them all. Pokemon? You know why Pokemon? Why Pokemon? Huh? Yeah, but why Pokemon? Why Pokemon? No, I was like, but why the name Pokemon? Pocket monsters. Yeah, it was like small. They put them in. They were pocket monsters. Hence Pokemon. And I was like, whoa, that makes a lot of sense. Explain to me Bakugan then. Has to be some kind of underlying ball thing. Is that what that is? Ball game? I don't know. But Pokemon, I'm like, yeah, Pokemon. Alright, here we go. Thank you. Find for me, please, whether this has 1, 2, or 0 solutions. 2 and 0. I was thinking in my mind for the thing. 2 solutions, 1 solution, or no solutions. Andale, go. You can use that crunchy crap on your arm. Andate, move that pencil. Pen. Bolígrafo.
Didn't they lose last night?
Oh, are we doing They lost to the Saints.
Where's my soccer fans?
Loses to the Saints.
Puro America, 4-1. No,
No, sir.
it's me by myself.
I was watching football. I was busy doing American.
I was watching football.
Like real football, not football.
I was really watching football, petting dogs,
Football, not that.
backing up
Old fashioned jigs. They always come.
Be cautious of the court, sir.
I actually have to go through my 2 other programs. Just going down this week. I'm lazy enough to make it. I'm lazy enough to make things happen that I can be lazier later on. We get the square root of -4. Y'all should be counting.
I'm like, why is this a big one? But I do love chocolate. Okay, so what'd you guys get? Raise your hand if you got two solutions.
Well, I mean, what type of?
Two real solutions.
We did not in fact get two reasons. They should be mandatory.
Shut up, Evan.
One real solution. Zero real solutions.
Hey.
Two imaginary solutions.
Hey.
Good. Good. All right. That's all I got, guys.
Wait, but how far did you want to take?